Hello everyone, this is Advanced Chemistry online tutoring for IIT JEE, NEET, IB and the K12 curriculum. So I am Sundar Natarajan. I am an IIT alumnus. For more information about my projects, my experience, you can go to my website www.nisitolabs.com and have a very good look at it. Now in this particular video, I'm going to talk about how I teach through online advanced chemistry concepts to students. So let's start. Now teaching methodology which I do is with software because I am a software expert with chemistry. So I integrate always the advanced chemistry concepts with the software. So I have developed a software for education called CBR software, which caters the need of problem solving. It also caters the needs of problem content creation, which always need to be triggered, and it will activate analytical and cognitive ability of the students. So this teaching methodology, along with the online software, I create my own problems on my own, which is relevant to IIT JEE for IB and other curriculums. I also focus more on the problem solving approach, which is very important, and guide the students through a machine learning based software algorithms, which will take them from the initial stages from step 1 to step 2 to step 3 and step 4, and then finally make a student more activated in terms of their analytical ability to solve complex problems and then come out victorious in various examinations. So here is a sample problem which I have created on my own, and that is into organic chemistry. Now if you see the problem, it says that 6-oxoheptanal was obtained from A by ozonolysis followed by zinc hydrolysis. B on treatment with alcoholic KOH gives A. B on treatment with silver nitrate solution gives very pale yellow precipitate insoluble ammonia solution. Find A and B. So in this problem, what I have done is I have taken three particular blocks of concepts and then merged it into a very single problem that will kinder your cognitive ability. If you see the first block is about the IUPAC nomenclature, naming of compounds. We have to do practice of minimum 100 compounds with new rules. So that is very important. So here you have 6-oxoheptanal. So you should know how to write structure for that. So you have to practice more on that. Second one is ozonolysis comes under alkenes chapter. So ozonolysis, you have to understand it through a mechanism. How ozonolysis occurs through practically the mechanism. Once you understand the ozonolysis concept, then you know that what kind of alkene can be formed. Next is what reagents are used are also very important for reactions. So here we use alcoholic KOH. How alcoholic KOH is different from aqueous KOH. So we should know all these concepts, and then the reagents will knowing the reagents for each and every reaction will help in solving these kind of analytical problems. The last one, the last block which I took is for purification of organic compounds. So you should know how the organic compounds are based. For IIT JEE, this is very important, where you have to know the compounds, whether what precipitate is being formed and what is the color and how it reacts with what solution and things like that. So a combination of, if you don't know the combination of all these four blocks, then you cannot solve this problem. But this problem, we'll see how I'm going to approach and how I'm going to solve this. So let me show you how it is done, and I'm using an online editor here. So the compounds which 6-oxoheptanal. So 6-oxoheptanal is going to be like you have CHO, and that is going to be connected to the oxo group. Here comes your oxo group, C double bond O, and let me remove this. So you can have, so you have here 6-oxo C double bond O, and you have CH3. So this is what is this is your 6-oxoheptanal. 6-oxoheptanal, sorry. So when you have this, what we do here is we remove this according to the ozonolysis, this double bond O here, and also here O is going to get removed. So the alkene that is going to be formed here is in the form of, if you do, first of all you do ozonolysis, and if you do ozonolysis it is O3, and you do zinc hydrolysis followed by zinc hydrolysis. When you do this, so you should get an alkene. So alkene formed here is, it is going to be, this is the alkene that is going to be formed. You have a double bond and you have a methyl group. So this is the alkene that is going to be formed. But in the question what is given is, this compound is going to be formed from an alcoholic KOH is the reagent that is being used. So alcoholic KOH, like what is the use of it, and the reagent side, if you consider KOH aqueous is going to give substitution reactions, whereas alcoholic KOH is going to give you elimination reactions. So we should know that is something is going to be eliminated here. So what is that reactant that is going to be eliminated here? It can be two different. Here it is going to be this. So this is going to be my methyl here, and then you have here one X group. We don't know what is the halogen that is going to be removed. So you have a methyl group here. Here it have a methyl group, and you have an X. We don't know what is the X here. We don't know what is X. So here if you do an alcoholic KOH, you get two alkenes. One is like here you have, this is called your alpha atom, alpha carbon atom, and you have here this is beta, and you have another beta being formed here. This is also a beta carbon atom. So you have two betas. So two betas, you have hydrogen here as well. You have hydrogens here, and also you have hydrogens at the opposite side. Here also we have one hydrogen. So these two are acidic hydrogens. So we have two different alkenes that can be formed. But the alcoholic KOH, what happens is that the alkene which is more substituted is going to be the product. So that's why you get the product as this. So this is your product A. This is product A, and this is your product. This is your product already given. Given here it is called 6-oxo heptanal is what was the product that was given actually. So you have CH3. So the compound that is formed here B is what we got it. But we don't know whether from the purification of compound X is what. So X is basic nothing but X is going to be here, is going to be iodine, because iodine is what that gives you an pale yellow which is actually insoluble in your ammonia solution. So this is how I create a problem, and then I'll work on this kind of problems to create anti-reliability in organic chemistry. For more informations on the problem content creations, and if you want one-to-one face-to-face talk on this particular concepts, you can always approach me, and we can always have a chat on this, and we can have a very good sessions future. So if you have any face-to-face, you can always approach me for a particular session, and we can take things from there. Thank you very much.